We were talking about context-free languages last time. Maybe I'll give you a little reminder. I think I finished off with sort of a schematic diagram that's kind of maybe where we're going with this. There's sort of this hierarchy of languages, as we call them. The regular languages are kind of like the simplest ones, and we spent the first several weeks talking about regular languages. And then the next largest category is what they call the context-free languages. And these are the ones which can be expressed using grammars, using context-free grammars. Remember, context-free means that the left side of the arrow is always just a single big letter. And for example, like a particular language which is context-free but not regular would be something like a to the n, b to the n. That is context-free language, but it's not a regular language. As we know, you can demonstrate that using derivatives. Something, of course, we know many examples of regular languages. Anything you can write with a regular expression is a regular language. In particular, something like a to the n, just a to the n is regular. And then there are languages that are outside the category of context-free languages. And I mentioned this once, maybe last time, I don't know. But it is true, actually, a to the n, b to the n, c to the n is not even a context-free language. We'll talk a little bit more about that. But what I want to talk about today is basically working with context-free languages and context-free grammars. So given a context-free language, give a grammar for it. That's really what I want to talk about today. All right? And strategies for doing this. There is not a single there's not like a single thing that you always do. And there are some examples which are quite difficult of these, but we're going to talk about some general strategies. Given a context-free language, give me a grammar for it. So, some basic strategies. How do you make a grammar for a language? If I just describe to you a language as a set or something. Basic strategies. So the first one is maybe the simplest, and that is if the language you're talking about happens to be regular already, regular languages, you can make an NFA out of them and then convert to a grammar in a way which we discussed last time, not exactly last time, but in the past we have discussed this. So make an NFA and then convert to a grammar. This is a very easy procedure. You have to remember how to do it, but if the language that I'm talking about is regular, then you can make an NFA for it and convert it to a grammar. And the way this conversion goes is basically if you have some kind of states like this and an arrow between them, this becomes the grammar rule, x goes to ay. And if you just do that for all of the arrows in your diagram, this will convert the NFA diagram into a grammar. And there's essentially never anything that makes that hard. So this is the very easy case. If the language happens to be regular, you can always make an NFA out of it and convert it to a grammar. All right, what about non-regular languages? Those are really the more interesting ones from our point of view. And the general strategy that is used is one which involves what I call balancing. I would say the hallmark of a non-regular language, at least the ones that we've seen before, is like this, a to the n, b to the n, right? And what makes this not regular is really because of this repeated n. And that's why, like if you think of this in terms of derivatives, the fact that this n is the same both time means that if you take derivatives and cancel some of the a's, you'll get different answers every time. And that's what makes it non-regular. So I refer to that kind of thing, these two n's, as balanced. It's like the number of a's is balanced with the number of b's, all right? And how do you handle balancing like that? So for instance, the very standard example of a balancing type of situation is this, a to the n, b to the n. And here we have each a is balanced with one B, right? And they go in that particular order, all the A's first, followed by all the B's. And the way to make a grammar that accomplishes this type of balancing in our grammar, the solution is we must produce each A in the same step as its corresponding B. All right? And that's why, in this example, I mean, we've seen this example already, but that's why you do it like this. A goes to ASB. So the step that you use, the grammar production, that's what these arrows are called. The grammar production creates the A and the B at the same time, all right? You must create them at the same time. And then you say or epsilon in this case just to make it so that you can stop the derivation at some point by doing this or epsilon. All right? You must make the A and the B at the same time. Simultaneously. All right? You may be tempted to say something like, can I do like S goes to A, T, and then T goes to B, or something like that? This, generally speaking, will not work correctly. Because here the A and the B are not being created at the same time. Now, actually, this doesn't have any kind of iteration in it at all, but you might think about maybe put a S here or something like that to make it so that you can loop. This kind of business is, generally speaking, not going to work. You need to create the A and the B at the same time, not in two separate steps. All right? That's how you accomplish balancing. Now, in this is a simple example where it's just the number of A's is just straight up equal to the number of B's. We can do some simple variations, though, and you'll begin to get a feel for this thing. So here's another. This is a variation. A to the n, B to the 2n. How about that? So I would think of this as balancing somehow. I would like to think of it somehow like each A is balanced. In this case, I would say each A is balanced by two B's, right? That's the difference. Here we have twice as many B's as A's, but in terms of like the balancing act here, each one of the A's sort of comes with two B's, all right? And I think once you think of it in this way, it's not so hard to modify the grammar from the previous example. Anyone got an idea here? In the previous one, it was S goes to ASB. What do you think about this? Yeah? ASBB, yeah, I like that. And then I say or epsilon just so that the derivations can end. Yeah. So this way, every time you make one A, you make two B's at the same time. And then, of course, you can iterate through this thing to get longer strings. So, for example, A squared B to the 4 would be derived like, I hope you remember how these grammar derivations goes. The grammar derivations, you always start with S, and then you do the arrow up there as substitution rule. So I would do S goes to ASBB first, and then do that same rule again. The inner S becomes another ASBB, so it's now going to be ASBB, BB, and then that's actually what I want. I have two A's and four B's, and so we do the S goes to epsilon step just to finish it off. AABB, BB. And then I put a check mark because I'm satisfied with myself that I've been a good boy today. All right? Each A is balanced by two B's. If you think of these in terms of this balancing, I think these things become a little bit easier to handle. How about this one? This is another type of little variation. A to the n, B to the n plus 1. How do I think of this in terms of balancing? Now, it's actually not sort of exactly balanced, but I would think of this as each A is balanced with one B, plus there's just some extra B. There's one extra B, right? Plus there's one extra b. All right? So it's like a to the n, b to the n, only you need to make it so that there's just one extra b. You sort of want to insert an extra b somewhere, but here's a hint. You should not, it's not like this. I mean, this does have an extra b, but you're going to get an extra b every time here, which you don't want. You want only one extra b once. Anybody see how you could make that one? It's, again, just a simple variation on these other examples. You get just one extra b, only once. What do you say? Yeah?
S to TB and then T to ASB. Just add another.
Uh-huh. Okay.
Or you could just, instead of 4 epsilon, 4 B.
Yes, this is what I wanted to say. Although what you said first I think is also correct. Here's how I would do this. ASB or B, right? Instead of just inserting epsilon at the end, which means you just sort of stop, you insert an extra B at the end. I think that is the nicest way to do it. I think what he said before is also correct, though. He said something like, here's a alternative. S goes to TB, and then T goes to A, T, B, or epsilon, something like that. So this makes it so that you begin by just sticking a B at the end, but then you can continue by turning this into basically A to the n, B to the n. So this will also work, although I think this is a little nicer. Right? A little simpler. Great. How about, I got one more quick variation on this balanced stuff. I have a bunch that I would like for you to try also, but we'll get there eventually. A to the m, b to the n, such that m is greater than n. All right? So here also, I mean, it doesn't really look like balancing, but I want to think of this in terms of some kind of balancing where each A is balanced with a B, but there are extra A's. That's my interpretation of this, m greater than n. And not just one extra A. I mean, it could be just one extra, but it could be any amount of extra A's. So this is balanced, but with, can I say, several extra A's. Right? How do I make several extra A's? I mean, so like this right here, I'm going to do a variation on this. This is how you get one extra B. I would like to make, and so if you wanted one extra A, you would just put an A right here. I want to make actually several extra A's, and I think the simplest way to do that, so for this, I am going to use another big letter. I'm going to go ASB or say big A. And big A can turn into several extra A's. And so that I do like this, something like big A goes to AA or A. I want at least one extra A, which is why I put this A right here. But this says you can make the balanced one first, A to the n, B to the n kind of a thing. But then once you're done doing that a bunch of times, you just make it into this big A, and this big A can produce several extra little a's. So for example, if I want to do something like, if I want a derivation for, let's say, a to the 4b squared, how I would do that, I think of this as being a squared b squared, but with two extra a's. So first I go, s goes to asb, and then do that again, aasbb. So there's my two a's and two b's, and now I want two more extra a's. So now I make the big S into this big A, and then I can do the bottom rule there to just create two more extra A's. So I'm going to do it AA. Okay, one time, A goes to AA, BB. And then for the last time, I'm just going to do this A goes to just a single little A. A, BB, and that's it, right? So these are all simple variations on the basic kind of balancing idea, right? Balanced with some extras. Any thoughts about those? Like I said, I'm going to give you some to try. Two more simple tricks before I give you some to try. They are concatenations and unions. Let's talk about concatenations. Actually, several of the ones that I just did could also have been thought of in terms of concatenations. But the idea is something like, this is when you're trying to make a language which is built out of other formats that are stuck one after another. Something like this. How about a to the k, b to the k, x, such that x has an even number of a's, right? This is I'm going to think of this as a concatenation like this. I have that part and that part. The a to the k, b to the k part, that is familiar. I know how to do that as a balanced thing with a's and b's, right? So this, and then this is stuck on the end of this x over here. And this x has this property, all right? So this is a concatenation is what we call this. Really, it's a concatenation of a to the k, b to the k, which we already know how to do, and x such that, x has an even number of a's. All right? And each of those two languages we already know how to handle. Like the first one here, this is the basic balanced one. And the second one here is regular. Even number of a's. That's a regular language. We've seen that example several times before. And so the idea is you make a grammar for each of those two things, and then you can combine those two grammars as a concatenation, and that's very simple to do. So we make a grammar for each. We make a context-free grammar for each. And then paste them together like this. This is a simple trick, and it's easy to remember, I think. You just go, S goes to, I'm going to call them like S1, S2, like that. And then S1 goes to whatever. This is the first grammar. And then S2 goes to whatever. This is the second grammar. Right? The idea is you have two grammars for two different languages, and this is how you paste them together to make a single grammar for the concatenation language. You just stick those two symbols together, and then you paste together these two grammars over here. All right? So let's see if we can, and this, I suppose you should memorize this, I guess. I mean, it's not that complicated, but this is the trick that you do in order to combine two grammars together as a concatenation. All right? So let's see if we can do it in our example up here. We had the two parts of our concatenation were a to the k, b to the k. And this, of course, the grammar for that is s goes to a, s, b, or epsilon. That's the same. I mean, usually I write it as a to the n, b to the n, but it's the same example that we've talked about several times. The other one, this was x with even number of a's. I mean, x can have a's and b's in it, but it's just that the number of a's is even. This is a regular language, and I said before, the strategy for dealing with a regular language, I mean, maybe you could just invent a grammar for this out of nowhere, but to me it's a little easier. You should make an NFA out of this and then convert to a grammar. So even number of a's, that's this kind of thing, right? Something like this is NFA, which accepts, I should make the accepting state over here, right? For an even number of a's. Remember, when you're doing NFAs with like evens versus odds, it's all about going back and forth between two states according to the a's. And the b's just loop because I don't care anything about b's. I only care about a's in this case. All right. So if I were making a grammar out of that NFA diagram, this, you have to remember the process, but this is what I sort of said at the time, or I said, at the beginning today. I'll call those two states S and T, and then just every arrow you see translates into a production. So the arrow with the A going from S to T makes S goes to AT, and then I have B going back to S. That means S goes to BS. So those are the two outgoing arrows from S, and then the outgoing arrows from T would look like T goes to AS or BT. So that's the grammar for this one. And I should indicate something about the accepting state. Does anyone remember this procedure? How do in my grammar, how do I make the grammar reflect the fact that S is accepting? Remember this? Yeah? Yeah, for S, you say or epsilon. That's because S is the state at which you can actually finish the derivation properly. If you don't put this or epsilon, actually, these derivations can never finish because you're always going to just either have an S or a T in there and they never go away. That's the only way they can go away. All right, so I have 2 grammars anyway. This may take you a few minutes to work out each little part, and my final answer will be the combination of these 2 things in the way that I said up at the top there. S goes to S1, S2, and then S1 goes through the first grammar, S2 goes through the second grammar. So the concatenation grammar. I begin by just saying S goes to S1, S2, and then S1 is the first grammar, so I go A, S1, B, or epsilon. Here I am copying the first grammar here. Of course, if I'm thinking of this as being S1, then I have to make the other one into S1 also. Make sure you put S1 right here, not S, because this of course should only loop through this piece of the grammar. And then the S2 is the other stuff over there with the T's. So I say S2 goes to AT or BS2 or epsilon, and T goes to AS2 or BT, like so. All right. It's kind of complicated looking when it's all put together, but it's, you break it down into simple pieces and then paste the pieces together. All right. Any thoughts about that? So sometimes your languages are convenient to express as a concatenation, and this is a classic example. It's one thing stuck on the end of another thing. So it's very, to me, when I look at this, I immediately think of that as a concatenation. I will caution you, it may even be tempting to look at this as a concatenation of 3 parts, A to the K, B to the K, and X. If you think of it that way, then actually all 3 of them are regular, right? A to the K is just like A star as a regular expression, and the B also, and the X. Actually, you would be wrong to break it up in this way, because you should not, when you break it up as a concatenation, you better not separate this AK from the BK. It's important that they have the same exponent here, and if you just think of this instead of that, as if it were like A star followed by B star, then you lose the balancing. So that's actually a very different thing. So make sure when you are breaking things up in terms of concatenations, don't split up pieces which are actually sort of linked together. So a little caution there. All right. I said the last 2 tricks I want to talk about were concatenations, and the other is unions. If you think just for a moment, I think it will become clear to everyone what the appropriate thing to do is with the unions. But what about unions? Something like, how about just like the example we just did? A to the K, B to the K, but instead of one after another, I'm just going to say union X, such that X has an even number of A's. All right? Rather than these strings just being stuck on the end of each other, I just want a language which is either the first format or it's the second format. That's what union means, right? All strings which either look like this or they look like this. It is a very similar trick to what we just did to make the concatenation. For the concatenation grammar, you start by immediately putting one of these followed by the other one of these. For this case, I want instead to say it's like one of these or it's like one of these. Anybody can suggest how to change the basic approach here? Instead of one thing right after the other, you want just like one of these or one of these. Yeah? Put the bar, yeah, right here. It's instead of S1 followed by S2, it's just S1 or S2, and otherwise it's exactly the same. So to get the unions, maybe I'll put this in another box. To make a union context-free grammar, you go S goes to S1 or S2, and then S1 goes to whatever it is, S2 goes to whatever it is, all right? That's all it takes. Very similar to the concatenation trick. The only difference is it's a bar here rather than the concatenation has no bar there, all right? Because the bar means or, that's why this works. So this particular example here, for the union, I would say S goes to S1 or S2. And then the rest of it is exactly the same as when we did this example a moment ago. S1 is the first grammar, that's A, S1B, or epsilon. And then S2 is the second grammar, that's whatever it was. That was more complicated. AT or BS2 or epsilon, and then T goes to AS2 or BT. Yeah. All right? This is how to do a union. So when you are presented with a language, I would describe, here's some weird language. You make me a context-free grammar. It's sort of up to you to decide which of these various tricks you're going to be using. Should I think of it as a union of something or a concatenation of something or whatever? All right. I got a few more examples, and then I have some for you all to try. Let's try. This is just kind of a rehash of one that we did before, but I wanted to see how did I write this before? A to the M, B to the N, where M is greater than N. This is the one with extra A's, right? Now, you can think of this as just a purely, balancing with extra A's, as the way that we did a few minutes ago. This you can also think of as a concatenation. So let's see, and we'll see, we'll get the same answer. But this one, as a concatenation, you can think of this as some number of A's followed by balanced A to the N, B to the N, right? That's the idea here. It's some amount of A's, and I don't need to put a question mark, maybe a K or something. And then I can split it up as a concatenation like that. Since there were extra A's, we can just kind of peel off the extra A's and write it in a way so that there's just some extra A's first and then balanced afterwards. And now this we can represent as a concatenation. So of course that part is our old favorite. S goes to AS, B, or epsilon. And then the first part, A to the K, that's just a bunch of A's and then you stop. That would be something like S goes to AS or epsilon, right? Just repetitions of A's and stopping after a while. And so what's the concatenation of those two? It's, I write this S1, S2 thing, and then I go S1 is the first one, AS1 or epsilon, and the second one, S2, is AS2B or epsilon. All right. This is how we do it. It's not exactly the same format as the answer when we did this before, but this is kind of like, if you compare this to the way that I wrote this before, this is like the big A from before. Right? I had a rule that said big A goes to little a, big A, which is basically the same as this. This just creates a whole bunch of extra A's. And you know what? I realize there's a little mistake here. Anybody? I see some frowning faces, but maybe that's just your regular face. But anybody see there's a little technicality here?
Shouldn't S1 be AS1 or A?
Yeah, right. Here in the definition of the language, the M has to be bigger than N. I think the way that I made this, it would be possible that they're both equal. So this is for greater or equal, but if you want really greater than, it means this K is not allowed to be 0. There must actually be some extra stuff. So here, to make that happen, it should go S goes to AS or A, not epsilon here. Sorry about that. And so this S1 should go to, now I'm satisfied. This must make at least one extra A at the beginning, and then all the rest of it. All right. Great. How about, I got a fancier one here. How about, this is actually a little tricky. A to the N, B to the M, such that N is not equal to M. What makes this tricky is all of these variations on A to the N, B to the N, I have been thinking about in in the sense of like there's like extra A's or maybe there's extra B's. The problem with this one is actually you don't know which one has the extras, right? It just says there's not the same number. But are there extra A's or extra B's? The answer is, well, it could be either way, and it's not saying if there are extra A's or extra B's. There could be extra A's or there could be extra B's. Anyone have a thought about this? Actually, this one can be expressed as a union. It's not obvious to think of it in that way, but anybody agree with me? Can you think of this as a union of something? So in this case, the A's and B's not the same amount. It's useless for me to have written that. You all know what this says already. Can you express this as a union of things that we've already seen before? I just said the issue here is that we don't know if there's extra A's or there's extra B's. An idea?
Yeah, M is less than M or M is greater than M.
Yeah, right. It's either that there's extra A's or there's extra B's, and you can write that as a union. So this set right here is equal to the union A to the N, B to the M, where N is bigger, or A to the N, B to the M, where M is bigger, right? And that's a union, because I said the word or. And do we know how to deal with each of those two sets? Yeah, we do. They are the same types of sets that we just did in the previous example. So this one, if I were to, I think maybe this is a little easier to write with extra. So this one, the first one has extra A's. So I'm going to write it as S goes to ASB or the big A. This is just a little less confusing to me, right? Balanced, but then there's extra A's. And then the other one is balanced, but there's extra B's. So this one would look like S goes to A, S, B, or big B. Big B goes to A, not A, B. I'm trying to make extra B's here. B, or B. Too many B's. All right. And then I combine those two things with a union. And I hope everybody still remembers. The way to do that is you go S goes to S1 or S2, and then you just paste in all of those things. So S1 goes to AS1B or big A goes to A or A, and then S2 is the other one. All right, I think we get the idea. I had a couple more, but I wanted for you all to try some. So I'm going to skip my examples. Maybe I'll do those at the beginning next time, because they were a little fancier, and we don't need to get too fancy before we do the plainer ones. All right, let's try some for you all. So your job in each case is make a context-free grammar. For these. Can I just remind everybody, what does context-free mean again? It means a grammar, of course. Context-free means, though, that the left side of the arrow is always just a single non-terminal symbol. No funny business on the left side, although technically for grammars in general, you are allowed to put other weird stuff on the left side. But context-free grammar means that it's just a single letter on the left side. All right, anyway, see what you think about this. The first one is meant to be kind of easy, and then some somewhat fancier versions. My alphabets are always A and B here. And remember, the R means the reverse of that string. All right, see what you think. I'll give you one more.
This one, you can't make it less of a direction.
Okay.
That M has to match that M.
Yeah.
So it's really like balancing on the outside
Okay.
and then something on the inside.
Got it. Okay.
That's fine. Yeah, this is the same. Can't see it. This M has to be matching that. And if you split it like this, then it won't match it. So I think of this as balancing. The outermost part of it is balancing, and then inside of it, you make it straight. Well, it depends on what the set looks like. Like, this one looks to be more like a convention. That's things coming after things. That's what, whereas Unity is a set, which is like, either it's this kind of thing or it's this kind of thing. Yeah. How's it going? Mm-hmm. I like this. This is almost like this. The one is, I think, like, you can only make one paper in this. Because S becomes T easily and then you do this. But you want to be able to go through that several times. I like the general idea of it. How's it going? Hmm? Get anywhere? Okay. Searching. Yeah, yeah, I think that works. Yeah. Still good there?
Yeah, I'm probably not mistaken.
Yeah, this, I would say, is not really a concatenation, because this part, you can't split this apart from this, because these ends have to be,
Yeah,
linked.
that's the-
Yeah. So I would say, I mean, outside, it's like balanced with these.
Okay.
And then in the middle, there's just extra A's.
Okay. Alright.
Keep going. Mm-hmm. Yeah, this is good. Mhm. Yeah, yeah. Yeah, it's just same, except, yeah, great. How's it coming over there? Yeah, this is great. Mm-hmm. Remember what the R means?
Good.
It's the reverse, yeah, so it's like the first half of the string. It's about the same as the last half, but backwards. Yeah. How's it coming? Mm-hmm. This is pretty good. I think what you want is, yes, really should go in here, which would allow you to do this several times. Like as written, you can only do this once. Which means you can only do it. I think it should go here instead of that. And then, so you do this as many times as you want, and then maybe you can also change the S into a A or something. Yeah, yeah, yeah. Yeah, this one is a sneaky one because you should not pick it. Because this M has to be the same as this other, so you can't split them apart. So I would think of it instead as B's, B's, and these other, they are balanced. B or 3B's here. And after you do that a bunch of times, you make the middle. I
I think we got to talk about these. Sorry to abbreviate your time. The first one, pretty much everybody worked out. This you should think of as a concatenation, that part and that part. The first part is the ordinary balancing, and then the second part is just a bunch of extra A's. So I would have written, if you're writing this as a concatenation, something like this. And then the first one is AS1B or epsilon. That's to get the balancing of the first part. And then the second part is just A to the M, which I would make like S2 goes to AS2 or epsilon. So that's how I would have done the first one. Any comments about that one? I think pretty much everybody did fine with that. Maybe I'll, so this one is a little trickier. This one is maybe principally tricky because it looks like a concatenation, but actually it's not. You cannot break it up like this, for instance, because the M in the first chunk needs to be linked with the M later on, and you can't segregate them in this way. You can't consider this as separate from that because these are the same M's. So instead, I think of these as balanced with one another. So to get the balanced B's on the front and on the end, you need to begin with something like B, S, B, 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 right? This, and by going through this rule several times, you will generate one B on the front and three B's on the end, all right? Where the S, remember the way that these rules work, this S will always remain in the middle. And then, after generating a bunch of B's and, three B's over here, at the end, you want to create more A's in the middle. And this S is already situated in the middle, so I can do something like or big A, and then big A goes to AA or epsilon, something like that. So this first rule creates all the B's in that appropriately balanced way with 3 at the end. And then after creating all the B's that you want, you change the S into this big A, which makes extra A's. And they will occur in the middle because that's where this S has always been, in the middle. All right? That was a little tricky. Any thoughts about that one? All right, the other ones I saw not a whole lot of people made it this far, but we can talk about them. XX reversed. So these are strings like, for instance, AABA, ABAA, right? There's the X reversed, all right? This is some kind of weird sort of balancing. This is how I would think of this. Balanced in the sense that the A at the beginning matches with the A at the end, and then the next A here matches that A, and then this B matches that A, and this A matches that A, right? They're sort of letter by letter balanced. Something at the beginning always matches exactly the same thing at the end, all right? And so to achieve that, anybody come up with something? It's actually fairly simple rules here. You need to create the letters in such a way that you're basically always creating the same letter at the beginning and the end at the same time. Yeah?
ASA, BSB, or epsilon.
I like that. ASA or BSB or epsilon. Yeah, this, by doing these steps over and over again, you can create a string like this. So for example, to get that string up there, I would go S goes to ASA, that's because I have an A at the beginning and at the end, and then I have another A at the beginning and the end, so I make another, that same step again, now AASAA. And then I want to see a B next, so I do BSB. So this will be AABSBAA, and then finally I have two A's in the middle, so I go S goes to ASA again. AABASABAA, and then finally the S goes to epsilon. AABA, ABAA. Ha! That's it, right? A little cute, I think. Not so tricky. And what about, let's just talk about the last one. Maybe I'll save this, the number thing for next time. But the very last one was X equals X reversed. This is a string which is equal to its own reverse. That would be something like ABBA, right? Or something like AABAABAA. This is a string which is equal to its own reverse. You read it either way around, you get the same thing, right? The first question in your mind after thinking about this for a moment is, what, is that any different from what I just said? Isn't this the same as this? These ones, that is exactly this same string here, and this one over here also is of this format. What's the difference? Anybody say what's the difference? This means the whole string is equal to its own reverse. Yeah?
Could have ABA or something.
Yeah, this one you could have something like ABA, or maybe BABA, BAB, bababab, right? The difference is these have an extra letter in the middle, which is, these would not be allowed up here because they have an extra letter in the middle. So, having considered that, really the only difference is this, I'm going to use the same grammar again, but I also want to allow one extra letter in the middle. And the way to make that happen is just instead of or epsilon at the end, I'm going to have the same main steps here. Instead of or epsilon is allowed. You could have nothing in the middle at the end, or you could have a single extra A in the middle or a single extra B in the middle. And remember, those extra guys will occur in the middle because of where the S goes. The S always inhabits the middle. And so this A and the B, when you finally stick them in, they end up in the middle, not on the end. All right.